Hello and welcome to my Pre-Algebra review series. This video covers Chapter 10, Section 5, titled Surface Area, Prisms and Cylinders. By the end of this video, you will have reviewed recent lessons regarding surface areas, finding surface areas of prisms, to including finding surface areas of a prism using a net, and finding surface areas using formulas. Then you will look at finding surface areas of cylinders. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it will certainly help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to answer each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Let's get into this one. Okay, let's start with some definitions. A surface area, labeled S period, A period. We pretty much see it that way all the time in here. The surface area is the sum of the areas of the bases and the lateral faces of a surface figure. We'll see more of that later on. And a lateral area, L period, A period, is find the surface of a prism by using the lateral area and the base area. The lateral area of a prism is the sum of the areas of the lateral faces. The lateral faces are usually the ones that rise up. The bases are either the top and the bottom, generally. Okay, in Objective 1A, finding surface areas of prisms. Prisms and cylinders can be right and oblique. So what we're seeing here is some pictures of regular prisms, which we're going to call a right prism. That's where the angles in the prism are all, excuse me, where's my pen go? Are all right angles. Like this is a right angle here, right? 90 degrees, right? This is 90 degrees. The box stands up straight, so to speak. But an oblique prism, it's kind of slanted. Like if you didn't have the backs in a cardboard box, you could kind of tip it sideways like this. I'm sure you've done it before, although a prism has the top and bottom under the bases. But you get the picture of how it's kind of leaning. And then what we're doing is we can measure the height of this prism from the vertex that's overhanging out here. As you see, it's outside now, to the line. What do they call it? The line containing the base. And this is the base, and this is the line containing the base. So the height is a perpendicular segment falling from the vertex down to the base. And then we'll see that in the oblique cylinder, same. A right cylinder has two ovals of some type, circles, for the bases, the lower and upper. And then the vertical, okay, the lateral surface is the part that you see rising here that makes the tin can part of it. And realize that this is the height of this. These are two circles, and this is the height of the lateral area, which makes a parallelogram or whatever. It could be a rectangle. It would be in this case. And you can see it because if you'd cut this down right through here, the can, and open it up, it would form a rectangle. It would look just like, it would open up like that. And here is the height, and here is the circumference of the can, right? Making a rectangle. And an oblique cylinder is the same thing like we did with the box. Imagine yourself that you took the top with your hand and you kind of smushed it in that direction, right? Kind of slid it to the right. You could slide it to the right, the left, backward, forward. But again, the vertex where the height is coming down is being dropped down to the base, that the line that the base is sitting upon, or the surface. In this case, it'd be the surface that the cylinder is sitting on. But this is an oblique cylinder. It's slanted to the side. The surface area, SA, is the sum of the areas of the bases and the lateral faces of a surface figure. We talked about that just now. The one way to find the surface area is to find the area of its net. You measure surface areas in square units. Remember, always in square units. Okay, example 1, finding surface area using a net. Okay, it says find the surface area of a rectangular prism using a net. Well, here's the prism they want us to find the surface area of right here. This is it right there. And let's look at these dimensions. We have a 20 inches long, 5 inches by 8 inches. And here's the net they drew. And let's, from the proportions in the net, let's see if we can find out which is the base. It looks to me that we have 20 inches here and 5 inches here. This is the base. We're going to call this the base, I think. No? We're going to call 20 inches. We have 20 inches by 5 inches. So I'm going to assume that this is going to be the base down here. Right here. 20 by 5. Seems that way. Because this is 8 inches is kind of going up. And I want to see the 8 inches here is rising. So if I fold along this line and bend this piece back toward me, it's going to be 8 inches tall. Okay? So that's it. I'm going to assume that that is the base right here. And if that's the base, this is the flap right here. This piece right here on this side is 8 inches tall. And it folds in. It's going to fold in. When you raise this up, it's going to fold in. It's going to swing in like on an arc over here, coming in this way after you fold it up. So anyways, now that we know which is which, so we have a 20 by 8. Here's 20 by 8, right? So all of these are 20 inches long. Everything is 20. The only thing we need to know that's different is the 8 by 5s. And this is 5. This is an 8 by 5 here and an 8 by 5 inches here. 8 by 5. So now you can do up all of the area of each one of them, the lateral area, right? To get the surface areas. So we're going to do 160 inches square, 100, which is 5 times 20. 160 is 8 times 20. Another 160, 8 times 20. They're all 20 wide. 5 times 20 is 100. So we have 360, no, 320, 420, 520, plus 40 and 40 is 180, or is 80 rather. So 520 and 80 is 600. So 40, 40, 60, 40, 60, 100 equals 600 when you add all those together. And that it is. The surface area is 600 what? Inches. What kind of inches? Inches square. 600 inches squared. Don't forget to include your units. Without it, you'll have an incorrect answer. Okay, example 1, check your understanding. So there's 3 questions here. 1 is find the surface area of the rectangular prism. 2 is a similar triangular prism, has dimensions that are twice those that's shown here. Find its surface area. And then C says, how do the surface areas of similar prisms compare when dimensions are doubled? It'd be easy. You just look at the 2 answers and you'll find out, okay? So go ahead, take your time, come on back, and we'll try it. Okay, I assume you're back. So first off, let's get the area of the triangular areas. The triangular areas are these here. And we know that the formula for a triangle, as I'm drawing this, is 1/2 the base times the height. Okay? And the base in this case is 4 and the height is 3. So the triangle 1, I'm going to call it triangle 1, is equal to 1/2 base times height, and that equals 1/2. I'm going to say 4 is the base times 3 is the height. That equals what? 3 times 4 is 12 times 1/2 is 6. 6 what? He might ask. 6 yards squared. So since these polygons are congruent according to the rules for prisms, so T2 is equal to T1 is equal to 6 yards square. So now we have 3 other rectangles to solve. So at rectangle 1, rectangle 1 is going to be this one here that's 6 by 5. Okay, that's this one. Is equal to the base times the height is equal to 6 times 5 is equal to 30. Okay? Again, yards square. Then rectangle 2, we can pick any one we want. Again, is base times height. And I'm going to pick the back one, which is 6 by 3. And that equals 18 yards square. And rectangle 3 is equal to the base times the height. And in this one, it's 6 times 4. The back is 6 long, and the side is 4. 6 times 4 is equal to 24, what? 24 yards square. So what does that equal to? I took up all the room practically. So what that equals to is 24, what are we doing? 6 and 6 is 12. 12 and 18 is 30. 30 and 30 is 60. And 24 is 84. So 80, adding them all up, is 84 yards square. I just added each one of these figures up. T1, T2, R1, R2, and R3. I ran out of room. Otherwise, I would have written it down. Now, a triangular prism has the same dimensions as those. What is its surface area? Well, the surface area, if you did that and you doubled each one of those, it's going to get very large. And without solving it, it's just a matter of doing the same math over again. I can do one thing. Let's just do T1. T1, if the areas are doubled, T1 is equal to 1/2 the base times the height, and that equals 1/2 times 4 times 3, or not 4, it's doubled, 8 times 6, or 6 times 8. 6 times 8. So 48, half of that is 24 yards squared. I'm running out, it's not writing. Okay, so now you can notice just from this one piece alone, you don't have to do anything more. You can look at T1 here, and it's 24 yards. T1 on this side is 6. It's 4 times larger. Let's pick another one. I don't care, anyone, you name it. Let's do R3. R3 down here in the bottom is equal to base times height. Base times height is equal to, and R3 was the 6 times 4. 6 times 4, it's this base right down here. But instead of 6 times 4, it's 12 times 8, right? Is equal to 12 times 8. And 12 times 8 is 96. And what is half of 96? Or what? This is 96 yard, not half. Yards squared. 96. And what was the other one? 24. Well, 24 is 1/4 of 96. 96 is 4 times larger than 24. So I think you can assume that the area is going to be entirely 4 times, the surface area will be 4 times larger. So given 84 here, we're going to multiply that times 4, and we're going to get 336 yards square. Okay? So that's what we're going to get there on that one. So that's what happens when they doubled. You're going to get, I didn't do it, I actually did not, this number C over here, but it is 4 times larger. Okay? Objective 1B, finding surface areas of prisms. Another way to find the surface area of a prism is to use a lateral area and the base area. Lateral area of a prism is the sum of all the areas of the lateral faces. And the bases are the 2 parallel bases that we have that are congruent. Just like the triangle, you find one, you know the other one automatically. So we have, like if you look at here, you have C, A, B, C, and D. These are going to be the faces, A, B, C, and D, as it goes around the base. D, C, B. It's the same. It wraps it around. The perimeter of the base is A plus B plus C plus D. So the lateral area is, they're saying, is the perimeter times the height. So whatever the sum of all of these is, this piece going across here, whatever the sum of all that is, times the height. Times the height. So A plus B plus C plus D times all of that times H. And the surface area is the lateral area. It's this area here, the lateral pieces, all added up. The H times the quantity A plus B plus C plus D, plus the bases, 2B, two bases. So whatever the base is, and the base is C times B, or B times C. B times C is the area. It's the base times the height. And there's two of them. So 2 B's, okay? Okay, objective 1C, that's the third slide in the objective 1. Finding surface areas of prisms. Here's the key concept. The surface area of a prism. The lateral area of a prism is the product of the perimeters of the bases and the height. So you go around the perimeter of the base, around the perimeter of the base. If you can find the perimeter of the base and multiply it by the height, you know the area of the lateral. These are the lateral surfaces. Okay, you know the area of those. That's pH, perimeter times the height. The surface area of a prism is the sum of the lateral areas. Surface area is the lateral area, that's this, the perimeter times the height, plus 2 B's. That we just went over that, but they're repeating it for you as a key concept. 2 bases plus all of the lateral areas. You find one base and multiply it by 2. Okay, example 2, finding the surface areas using a formula. So find the lateral area in step 1 here. What is the lateral area? LA is equal to the perimeter times the height. So remember, we look at all of these lengths here. The perimeter here is 5 and 5 and 6. That's 5 plus 6 is the perimeter, and times the height, or the length of it, is 12. So we get 5 plus 5 plus 6 times 12. And that comes out to 16 times 12 is 192 centimeters squared. Remember the square. And then step 2, find the surface area. So surface area is the lateral area, the LA. Where'd it go? Right there's my pen. The LA plus 2 times the base. Okay, and when we substitute in here, we got LA gets 192 centimeters square plus 2 for the B's. And what is B? The B is 1/2 6 times 4. Well, where did you get the 4? Well, I get the 4 because if you look into our problem right here, here's the 4 right there. It says there, right there is the height. Right there. The height of our triangle. So you have to look for that. There it was kind of hiding in clear space. So 1/2 6 times 4 is 24. If you times 2 is 24. 6 times 4 is 24. Divided by 2 is 12. Times 2 is 24. 192 plus 24 is 216. The surface area of the triangle, I guess I should say. I'm going to triangle. Let me correct that right there. Triangle is 216 centimeters square. Example 2, check your understanding. Find the surface area of the prism on the right. It's a rectangular prism, so it should be easy. Everything is straightforward area for the surfaces. So go ahead and try it. When you get back, we'll do it together. Okay, now that you're back, step 1, the lateral area, lateral LA is what? Lateral area is the perimeter times the height. And the perimeter is the length of the segments that make up the base. And then those are 3 plus 4 plus 3 plus 4. That's the That's the perimeter. You add up all these lengths around here. They're all going to add up, and you're going to get 3 times 4 times 3 times 4, all times 6, the height. And this is 14. Okay. 7 plus 7 is 14 times 6. So the LA, lateral area, is equal to what? Let me write this in. 14 times 6. And 4, I'll just write it here again. 4LA, L period, A period, is equal to 14 times 6 is what? 6 times 10 is 60. 6 times 4 is 24. So it's going to be 84. 84, what do we have? Meters square. Notice how it's meters squared? Okay. So now how about step 2, the surface area? SA, S dot A, is equal to the L dot A plus 2 times the base, or the bases. And we know that the bases are what? The bases are the 3 times 4, 3 by 4. These are we're sitting on the bases. Okay, we've got the perimeter, and now we need the area of the bases. So SA is equal to, what was it, 84 meters squared plus 2 times B. And what is B? B is using the standard area of a rectangle is base times height. Well, pick anyone as base and anyone as height. It's base times height 3. So it's 4 times 3. And then what is that equal to? So the S dot A, surface area, is equal to 84 meters squared plus 2 times 12. 4 times 3 is 12. 2 times 12 is 24. Again, meters squared. We're going to add them up. So the SA, S period, A period, is equal to 84 and 24. 80 and 20 is 100. 4 and 4 is 8. 108 millimeters, or meters rather, excuse me, square. I'll write it over here. 108 meters square. Okay, we'll find ourselves at objective 2 now, finding the surface area of a cylinder, or of cylinders. You can cut the label from a soup can. You will see that the label is a rectangle. The height of the rectangle is the height of the can, and the base length, the long length of the rectangle, is the circumference of the can. We've spoken of this already. And you see it right here. You see this rectangle, height and 2 pi r, it says, this is your rectangle for the label. And here again on your cylinder, we have a height and a circle. And a circle is what? What is the area, or the area of a square? Is pi r squared, right? So the base is pi r squared. That's the area of the base. We have 2 of them. So you see they're showing you there's a base up here, a little base up here, and looks like a little base down here, and then here's the rectangle. So they're adding them together like a net diagram. So what do we have? We have SA is equal to LA plus 2B. So the LA is the long piece and the 2B. Okay? Concepts. The surface area of cylinders. The lateral area of a cylinder is the product of the circumference of the base and the height of the cylinder. So you find out the circumference of the base, which is pi d, or 2 pi r. That's here, 2 pi r times h. Well, you get the circumference, and then the base, the height of the cylinder. 2 pi RH, right there. 2 pi RH. The surface area of the cylinder is the sum of the lateral area and the areas of the 2 bases. So the LA, as we said before, is 2 pi RH. And then you've got the 2 bases. And the bases is pi r square. Okay, so it's 2 pi r square. And here's the pictures over here. You see the bases and everything. So let's move on and do the problem. Okay, let's see how this is. Packaging. Find the surface area of the can at the right. Okay, there's a sardine can at the right. 3.5 centimeters in the radius and 11.5 centimeters for the height. So find the lateral area first, step 1. LA is 2 pi RH. 2 pi r. 2r is the d, right? And pi d is the circumference. h is the height. So we have 2, and this is the surface area. We're talking about it's an approximate area now, right? We don't know for sure. And why is that? Because we're taking and using 3.14 for pi. It's not an exact, it's an approximate. But it's 2 times pi, 3.14, times 3.5, which is the r is the radius, 3.5, and 11.5 is the height. We take all that, we multiply all this out, 2 times 3.14 times 3.5 times 11.5, we get 253 centimeters what? Centimeters squared. You multiplied centimeters times centimeters. Okay, now find the surface area. The surface area is the LA, 253 plus 2B, 2 bases of the cans. So what do we know for the bases of the can? Well, first of all, what do we know for the surface area? It's the LA, 253 plus 2 times 3.14 times 3.5 squared. That's the r squared. Pi r squared. And it's 2 pi r squared because there's 2 cans. That's the 2 from the 2 B's. The bases is the pi r squared. So you get 253 plus 77. This 2 times 3.14 times 3.5 squared is 77. When you add those together, and these are, they're all approximate, right? Why are they all approximate? You see how it's got the little approximately equal, little squiggly equals? That's because we don't know. They're not exact because we use 3.14, and that is not pi. That is a close representation of pi, but as we've said before, pi is a non-repeating decimal that goes forever, never repeating. So we can never get the exact answer for pi, but to get very close. Anyways, it's 330 centimeters squared as the area of that can. Example 3, check your understanding. Find the surface area of a can with a radius of 5 centimeters and a height of 20 centimeters. Okay, this is going to be your problem, but before you go, I'm going to go ahead and draw a little. I'm going to draw a can for you. And it's 20 centimeters and 5 centimeters for the radius. Okay? Go ahead and take off and do it. That'll ought to help you a little bit. Okay, now that you're back, let's do the lateral area. The lateral area, the LA, is equal to what? It's the circumference of the base. I'm going to change colors. The circumference of one of the bases. And the circumference of a base is 2 pi r. Well, we have r, right here is 5. So it's 2 pi r times the height. And the height is 20. So the LA is equal to 2 times 3.14 times 5 times 20. And when we take that out, it's 2 times 5 is 10. So it's going to be, here, let's do it easier way. 5 times 2 is 100. 5 times 20 is 100. 2 times 3.14 is 6.28. So 6.28 times 100. And that equals 628 in its centimeters square. Okay, we have that, 628 centimeters. Now we're going to do the SA. SA. I switched apparently to red, I guess. We're going to have to live with it. The SA is the area of the lateral, is equal to the lateral area plus 2 times the base. And we know now that the lateral area is 628 centimeters square. And it's plus 2 times what? And the base is pi r square. So it's pi r square. Okay, so 628 cm squared plus 2, and what is r squared? I'm going to write it out. 2 times 3.14, I'm taking that out, times 5 squared is 25. 628 centimeters square plus 2 times 25 is 50 times 3.14 cm, and that equals, this all equals, SA equals 628 cm squared plus, when you multiply this out, it's 157. 157. I did it on my calculator, cm, because I'm not going to try to do that in my head. Okay, so now sum total of that is 128 plus 150, so 728 plus 50 is 778, plus 7 is 785. 785 cm squared. There it is.